Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Smooth Operator. It's a smooth operator by Chinstrap. And here are the rules. We have 0 through 8 Sudoku rules apply, where we need to place the digits 0 through 8 once each in every row, column, and 3x3 box. We have arithmetic symbols, where a digit in a cell containing a symbol is the result of performing that operation on all of the adjacent squares pointed to by the symbol. What does it mean to be pointed to the symbol? Maybe that will give us information. Specifically, the digit in a cell with a plus in blue is the sum of all up to 4 orthogonally adjacent cells. So, for example, this cell must be the sum of all 4 orthogonally adjacent cells. Interesting. So we could have something, and this would be the sum of the 3 cell. Okay, what is an orthogonally adjacent cell? An orthogonally adjacent cell is basically just a cell that shares an edge with the cell. So these would be the orthogonally adjacent cells around this plus. So say this was like 1, 0, and 5, then this would have to be 6, because it's the sum of all cells that share an edge with it. The minus in yellow, so the pluses are in blues, the minuses are yellow, is the difference of the adjacent cells to the east and west in some order. So this must be the difference of these two digits. So for example, say this was 7 and this was 2, this would have to be 5 for that to work, because this is the difference between the two digits that are east and west of the cell. Multiply in green is the product of all up to 4 diagonally adjacent cells, which means the cells that are here. So this would be the product of these 4 cells. So say this was 3, 6, 0, and 8. Then this would be equal to 0, because 3 times 6 times 8 times 0 is 0. So that's how multiply works in green. And divide in red is the quotient of the adjacent cells to the northeast and the southwest in some order. So this is the quotient of these two cells divided together. So we could have, say, something like 4 here and 1 here, and then this would be 4, because 4 divided by 1 is 4. Interesting. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. Let's see. So for the multiply, I think to multiply 4 numbers, it has to be, to get a single digit number, it's going to have to be either very small or you need a 0 in it. And then it will multiply to 0. This is always going to multiply to some number. It cannot be 1 with the number, right? Because if it's 1 with that number, they're already all in the same box, and there would have to be a duplicate in that box. So it's either 2 and 3 or 2 and 4 multiplied together. So this must be 2, 3 or 2, 4. And either way, there has to be a 2. So this is going to be 6 or 8 here. Hmm. How do we get two sets of digits and then they multiply together to get to a single digit? Again, you could have a 0, but that would preclude 0 from being here. 0 would have to be one of these two digits, right? And we can only have, so that means we can only have 1 0 here also. So one of them is going to have to be a valid number. Well, this is at minimum, so if assuming this is not 0, this would have to be 1 and 3 at minimum, which could be with 1 and 2. That could work. You could also have 1 and 4 here, right? The minuses can never be 0 because they're all, yeah. And it could be 1 through 7 for the minus numbers. This one specifically cannot be 0 times, or cannot be 1 times 2 here. So to multiply together, you have at minimum 1 times 3 and 1 times 2, which would make that 6. Or 1 times 2 and 1 times 4 and 1 times 2, which would be 8. Or this could be 0. This, however, could be 0, 4, 6, and 8. I think one of them is definitely going to have to be 0. Because if you try to have... Yeah, because one of these has to have a 1 here, right? So if you have 6 here, it's 1 and 3 and 1 and 2. If it's 8 here, it's 1 and 4 and 1 and 2. Oh, I guess there's no 9 possible. So there's no 9 possible, so you can't have 3 times 3. 2 times 2. Oh, you could have 2. No, 2 times 2 doesn't work, right? 2 and 2 cannot be in the same row. So they have to be different digits, right? 1 and 2 and 1. So therefore, one of these is going to be 1. So either this is 1 and 1, 1 and 2, or 1 and 3, or 1 and 2, and 1 and 4. So we're guaranteed to have a 1 and 1. Oh. Okay, well, that's helpful. We know this difference there has to be a difference here. And the problem is 1 and if we try to make this 6 or 8, you have to have 1 and 2 here, and this is this 1, 3 or 1, 4. But the problem is, if this is 1 and 2, this difference is only 1. So this cannot be 6 or 8 then. This is 0. So this is 0, which means this can't be 0 here. This difference, then, we don't know. We just know there has to be a 0 here. This has to be 1, 2, 1, 3, or 1, 4, and so is this. So it cannot be 1, 2 because of the problem that we have for the minus again. So this is 1, 3, or 1, 4 here. So then this would be a difference of 2 or 3 here. Why is it not clicking? Okay. So 3 and 1 has a difference of 2. 4 and 1 has a difference of 3. Either way, this can't be 1 or it can't be 3 because we're guaranteed a 3 here, right? Either this is difference of 1, 3, which makes that 2, or this is a difference of 1, 4, which makes that 3. So this cannot be 4, which is 1, 2 times 1, 2. It has to be 1, 3 times 1 and 2 guaranteed here. Okay. So we have a 1 and a 2 guaranteed here. This has to be 0. That means the remaining digits in row 7 must be 3 through 8. Well, this is at minimum 3 and 4. 3 and 4 plus minimum of 0 and 1 is exactly 8, which is the maximum this digit could be. So this has to be 8 with 3 and 4 here. And this has to be a 0, 1 pair, but this can't be 0 because of 0 in the row. So this is 1, that's 0. To add up to 8. Remaining digits in row 7 have to be 0, 5, 6, 7. And yeah, this 3, 4 pair eliminates 3, 4 in the rest of the box. This can't be 7 anymore to have a difference because it would have to be 8 and 1 here, and we already have an 8 in the box. Remaining digits of box 8 are 1, 2, 5, 6, 7. Okay. This cannot be 8. This is at minimum 2 and 3 here. But it could still be 0, 1, 2, 3. I think we have to have 0 and 1 always here, right? If you don't have 0, the minimum is 1, 2, 3, 4, which doesn't add up to a digit. If you have 1 through... If you don't have 1, the minimum is 0, 2, 3, 4, which adds up to 9, which can't be in this puzzle. So we're guaranteed 0 and 1, so this is a 0, 1 pair. And this has to be... 1 eliminates 1 from being there. This has to be 2 and 3 or 2 and 4, adding up to 6 or 7 here. That eliminates 2 from the rest of the column. That means this has a difference of 5 or 6. If it's a difference of 5, it could be 6, 1 or 7, 2. If it's a difference of 6, it's 7, 1. So either way, 5 cannot be either of those cells. But that doesn't really tell us too much. Remaining digits in column 5. We have 3, 4, 5, 6, 7. This again cannot be 3. This has a this cannot be a difference of 7, because if we have a difference of 7, it would have to have 8, 1 here, and that would eliminate the 1 possibility being there. So if it's 6, it could be, yeah, it could be many things. We just know the rest of row 5 cannot contain 1 or 3. Okay. So that leaves 0, 2, 4, 5, 6, 7, 8. And 0 cannot be either of those. These could be any multiplication because that's fine. This is the sum of so this has to be at least 0, 1, 2. But if it's 0, 1, 2 to add up to 3, we'd have 2 and 3 here, which would eliminate all possibilities for that cell there. So this can't be 3. This is at least 4. So this is 4 through 8 there. Obviously, this can't be 0, 1. It could be 7, though. So this is 2 through 7 here. It cannot be 8 because 8 plus 2 other digits from 0 through 7 must add up to 9 or more, which is not possible. We have a guaranteed 1 in columns 1 and 3 in box 4. We have a guaranteed 1 in columns 1 and 3 in box 7. Where is the 1 then in column 2? It has to be here. So this is 1. This cannot be then 0, 1, and whatever digit. So it has to be at minimum 0, 2, 3, which means this can't be 4. It's 5 through 8. Can it ever be non-0, non-1? The answer is no, because again, you have 2, 3, 4 as a minimum then. So this is guaranteed to have a 0. So we have to have a 0 here. You can't have 7 anymore here. So this is 0, 2, 3, 4, 5, 6. That's possibility. So 0 is guaranteed here, 0 is guaranteed here. Where is 0 in row 3? It must be one of those two. 0 is here, 0 is guaranteed to be here. Where is 0 in row 4? It must be one of those three. We cannot have 7 here. Because 7 can only be divided by 1, which would require then the quotient to be 7, and then we'd have a repeat in this row. And the same with 5, right? 5 can only be divided by 1, which would leave a 5 there. We'd have a repeat. So this cannot be 5 or 7. 4 could be, this could be, oh wait, it could be 7, 7. And then that's 1. Okay, so this is, so it could be 7, 7, and then that's 1. Okay, right. So then this could be 1. What other digits could it be? What are the dividends you could have? I think it's 1, 2, 3, 4, right? But only if 8's available in one of them. And then 2 would have to be available in the other one. This can't be 1 because of 0, 1 in the row. No, you could have 5 through 8 also here. This one cannot be. Oh, this can't be 0. You can't divide by 0. So whereas 0, 0 has to be here, which means this is 0. That's where I placed it earlier. Interesting. Yeah, this can't be divided by 0. No division by 0, essentially. But this could be like 8 with 1, and then that's 8 there. That's possible. Remaining digits of box 2 are no 0, 1, 2, 3. No 0, 1, or 2, so 3 through 8. So 7 divided by 5, 7 and 5 divided by 1, or yeah, essentially we could do that, is 5 or 7. 4 divided by 1, so this is 4, 5, 6, 7, if this is 1, right? So that's all potentially valid. If this is 2, you could have 4 here, 8 here. You could have 4 here, 2 here. You could have 6 here, 2 here, and that's 3. So those are all the values, period. Anyways. This is guaranteed to be 2, so this cannot be 2 here. Where is 2 in box 8? It must be surrounding the minus sign. So this has to be 2 here, must be with 7 to make that a difference of 5. So this is 2, 7. This cannot be 5 or 7 here. So it's 1, 6 as a pair. 5, eliminates 5 in the rest of the column. Interesting. So this cannot be 5 anymore. If we have 2 and 3, if we have 2 and 3, that makes that 6, so this would be a 4, 7 pair, so that's potentially possible. If we have 2 and 4 here, that's 7, which would make this 3 and 6. So this cannot be 6 here. Okay. One remaining digits of box 9. Well, we know one has to be one of these two digits here. Um, hmm. How are these multiplied together or divided together? So 8 and 8 gives you 1. 8 and 4 gives you 2. 7 and 7, 8 and 4 gives 8 and 2 gives you 4. 7, 7 gives you 1. 6 and so I think it's 1, 2. Oh, 6 and 2 gives you 3. So this is 1, 2, 3, or 4. Hmm. Okay. Interesting. Okay. Yeah, it still could be 8 divided by 4 is 2. That's possible. 1 eliminates the possibility from being 1 there because of 1 in the box. Oh, that's pretty helpful. That means this can never be 7 and 7, right? So this can't be 7. This can't be 4. I don't know how I got 4 from that, anyways. So it could be 4 and 2, which makes that 8. Or 4 and 3. Sorry. 4 and 2 makes that 8. 4 and 2 makes that 2. Or 6 and 2 makes that 3. So this is 2 or 8. This is 4 or 6. And again, if this is 2, 3, that's 6 there, which would make that 7, 4. So this can't be 4 here. So if this were 3 here, this would then have to be 6 and 2 divided together. But this would force this to be 6 and 7, which would eliminate all possibilities for that cell. So this cannot be 3 here. It's 2. That eliminates 2 in the rest of the box. And 2 in the column. So this is 7, which makes that 2. No 7 then in this column. And you can't have 6. I guess you could have 3 here. So this could be 3 also. So those are all possible. Hmm. Interesting. This can no longer be 7, because to get to 7, you would have to have 7 divided by 1. Hmm. Okay, what are these potential differences? Hmm. To have a difference of 6, it would have to be 8 and 2. Okay, so let's keep these clear. 2 and 8, if that's 6. If it's difference of 5, it can't be 8 and 3. It would have to be 2 and 7. Difference of 4 cannot be 8 and 4, can't be 3 or 7. It would be 2 and 6. So far it requires 2 in each of these. And this has to be 2. So if it's difference of 6, it's 8 and 2. Difference of 5, it has to be 7 and 2 because you can't have 1 and 3 again. Difference of 4, it can't be 8, 4, cannot be 7, 3. It has to be 6, 2. So, and then a difference of 2, you're guaranteed a 2 here. So this is guaranteed to be 2 no matter what, which means this can't be 2. This is 3. So this has to be 1 and 4 as a difference. That eliminates 4 in the rest of the row. So this can't be 4. These can't be 4. Therefore, this is 6. This is 6, which makes this 7. So that's a sum of 2 and 4. Which means 7 eliminates 7 here. So that's 3. This is 1, 4 times 1, 2, which is 8. That eliminates 8 from being here. So this cannot have a 6 surrounding it because it would be 0, 2, 6 at minimum. 3 eliminates 3 in the column. No 4 remaining, no 6 remaining. So no 6. This then has to be either 5 would have to be 2 and 7. Difference of 8. Sorry, difference of 2. No 6, 8. It could be 5, 7. It can't include 1, 3, or 4. So this has to be 2, 5, 7 as a triplet, which makes this a 0, 8 pair here. Okay, 6 divided by 2 is 3, so this is 3 here. No 3 here, no 3 here, no 3 here. No 3 in one of these spots, and 4 is eliminated from possibilities in the rest of the box, and therefore one of these two is a 3, which eliminates 3 in the rest of this row. So this cannot be 0, 2, 3 adding up to 5. So it's either 0, 2, 4 or 0, 2, 5 adding up to 6 or 7. What we know, though, is one of these digits must be a 2. Okay. 3 is here. 1 is one of those. The remaining digits in box 5 are 4, 5, and 7. No 7 here because of 7 in the column. These can't be 7 because of 7 in the box. Two remaining digits of box 4. We have 0, 2, 5, 6, 7. Obviously, 2 cannot be here. 0 can't be here. Remaining digits of box 6 are 1, 3, 4, 6, 8. No 3 in either of these columns because of 3 in the column there. No 3 in either of these rows because of 3 in the row there. So where's 3? 3 has to be here, which means this cannot be 3. This is 2, 4 as a pair, which multiply to 8. So this is 8. Remaining digits of this box 9 have to be 1, 3, 5, 6, 7. And this can't be 3. This can't be 3 because of 3 in the column. So where's 3? 3 has to be here. We know one of this can't be 5 or 7 because of 5, 7 pair in the row. So this is 1, 6 as a pair, which eliminates 1 and 6 in the rest of the box. This can't be 6. It's 5, 7 as a pair, which eliminates 5, 7 in the rest of the row. This can't be 5 or 7. It's 6, which eliminates 6 here. So this can't be 6. It's 7, which means this must be the sum of 0, 2, and 5. Because, again, 3 cannot be either of these because one of these is 3, and this can't be 3 either. So this has to be 0, 2, 5, which means the remaining digits in box 1 is 3, 4, 6, and 8. Obviously, 3 cannot be either of those. 7 and 6 eliminate 6 and 7 here. Remaining digits of column 2. We have 0, 2, 5, and 4. This can't be 2 or 5 because of 2, 5 in the row. This can't be 0 because, or 2, 4 because of the 0 and the 2, 4 pairs in the row. So this is 5, which makes that 0. 5 eliminates 5 here, so that's 2. 0 eliminates 0 here, so it's 4. So no 2 here. This is 0, 5 added up, which eliminates 5 in the rest of the row. So 5 has to be one of these two. We know 3 is one of these two. Remaining digits of box 7. We have 0, 3, 7, 8. No 7, 8 here as a pair. No 0, 3 here as a pair. So we have 7, 8, 7, 8 to 0, 3. 5 is one of these two. This can't be 2. Okay. So we have 8 divided by 4 and 8, which would give us 1 or 2. We have 6 divided by 6, which is 1. 5 divided by 5, which is 1. And those are the only possibilities. 8 eliminates 8 in the rest of the column here. This can't be 8 because of 8 in the row. This can't be 1 because of 1 in the row. One of these two is a 2. Remaining digits of row 2. We have 3, 4, 5, 6, and 8. No 3 or 8 here and no 3 here because of 3 in the box. Okay. 0 eliminates 0 here and 0 here. Five divided by 2 does not give us a digit, so this must be 1, which makes that 2. That makes this a 5 here. 5 divided by 5 is 1. So 2 cannot be here. Where is 2 in row 6? It must be here. 1 eliminates 1 here, so it's 4 and 1. That eliminates 4 in the rest of the column. 5 eliminates 5 here, so it's 4. That makes this 6, which makes that 7. No 6 here. It's 1, 4, 8 as a triplet. 4 and 5 eliminate 4 and 5 here, so that's 7. This can't be 7. This can't be 7. 5 eliminates 5 in the rest of the column. Where is 5 in box 2? It has to be here. So 5 can only be divided by 5 out of 4, 6, 8 and give us a digit. So this is 5, that's 1, which makes that 4. No 4 or 5 here because of 5 in the row, 4 in the column, so that's 6. 5 eliminates 5 from being there. 4 eliminates 4 in the rest of the row. That leaves remaining digits in column 8 as 2, 5, and 7. This can't be 5 because of 5 in the row, so this is 2 or 7. This can't be 5 or 6. It's 4 or 8. Remaining digits in box 3 are 2, 4, 7, 8. Okay. 7 cannot be here because of 7 in the row. Where is the 7 in box 3 then? It must be here. So this is 7, which makes this 5 and 7. 5 eliminates 5 here. So that's 2, which makes this 7, which makes that 5. 6 eliminates 6 here, so it's 1 and 6. 1 eliminates 1 here, so it's 8 and 1. 8 eliminates 8 here. 6 eliminates 6 here. Okay. So let's make sure we have everything kosher. 0, 2, 5 add up to 7. 0, 1, 2, 4 adds up to 7. 1, 0, 3, 4 adds up to 8. Subtract 4 minus 1 is 3. 7 minus 5 is 2. 7 minus 2 is 5. Multiply 1, 4 times 1, 2 is 8. 7, 5 times 7, 0 is 0. And 2, 4 multiplied together is 8. Division. 5 divided by 5 is 1, 6 divided by 3 is 2, and 5 divided by 1 is 5. So those are all satisfied. We should just be able to do normal Sudoku. 4 eliminates 4 here, so that's 3 and 4. 3 eliminates 3 here. So this has to be 3 here. We have a 2-4 pair in row 1, which eliminates 2 and 4 in the rest of the row. This can't be 2 or 4. It's 8, which makes this 4. That means this can't be 4 here. This is 3, 8 as a pair, which eliminates 3 and 8 in the rest. 4 eliminates 4 here. So that's 2, which makes this 4, which makes that 2, which makes this 4 and 2. 3, 8 as a pair in box 1, eliminate 3, 8 in the rest of the box. This can't be 8, it's 6. This can't be 6 or 8, it's 4. 6 eliminates 6 here, so it's 5 and 6. 5 eliminates 5 here, so it's 0, 5. 0 eliminates 0 here, so it's 3, 0. 3 eliminates 3 here, so it's 8 and 3. 7 eliminates 7 here, so it's 8 and 7. 6 eliminates 6 here, so it's 8, which makes that 6. Which eliminates 6 here, so it's 1 and 6. 1 eliminates 1 here, so it's 0, 1. 0 eliminates 0 here, so it's 8 and 0. And that's a solution. Pretty cool, actually. It's interesting how these operators work, especially with 0 through 8. There's certain limitations that 0 through 8 imposes. Overall, pretty fun. Nice little puzzle. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.